Lesson 83, Homogeneous Differential Equations. In this lesson, we are going to look at a strategy that we can use to solve variables separable differential equations if a dy by dx can be written as a function f of y over x, where y is still a function of x itself. This characteristic of what we call homogeneous differential equations allow us to still solve variables separable differential equations by making the substitution b equals to y over x. Or you can look at this expression as y equals to b times x. Using product rule, we can actually find its equivalent expression by taking the derivative of v multiplied by x, so dx dv by dx, plus the derivative of x, which is 1, and multiplied by v. Okay. Let's see how this becomes useful in the following example. We're going to use the substitution y equals to vx to solve this differential equation x times dy by dx equals to x plus y. The hints on the left will take you on a step-by-step approach to complete this question. So very first thing we do is we are trying to make dy by dx the subject of this equation. So that means I have to divide every single term by x. I have 1 plus y over x. Next, we see that y over x on the right side of this equation, which allows us to make a substitution as v. But I also know that in the box, the big star above, we know that dy by dx can be written in the form of x dv by dx plus v equals to 1 plus v. Okay, so now we have replaced dy by dx with dv by dx in the expression. Rearranging this, I have x dv by dx equal to 1. Now we're trying to solve this particular differential equation. So I have dv over dx equal to 1 over x. Looks familiar now, right? Let's try to solve for v. We can integrate 1 dv and integrate 1 over x dx on the right side. So here we have v equals ln x plus c, but we still need to write things back in terms of y. And if you recall, v is equal to y over x. Which means that y is equal to x times ln x plus c. And this is the general solution to this differential equation. So this is homogeneous differential equations in a nutshell. Now let's take a look at example 2. Here we have dy by dx equals to 4x plus y over x minus y. We want to write this equation in the form of dy by dx equals to f of y over x. So notice how we have the y terms as the second term in both the numerator and the denominator. In order to brute force y over x into this expression, I know that I must be dividing the terms by x. This gives me dy by dx equal to 4x over x4 plus y over x over x1 minus y over x as required. Part B. Hence, find the general solution to this equation in the form 2 ln x equals the f of y over x. Okay, so we know that we will be making use of this. Let v equals to y over x. So that's dy by dx is x dv by dx plus v, right? That's from product rule again. And so I can continue with dy by dx as being x dv over dx plus v from the first part, and then 4 plus v, right? Anytime I see y over x, I now call it v. Good. Let's simplify this slightly. I have x dv over dx equals to 4 plus v over 1 minus v minus v. I'm going to write it as a single rational expression. 4 plus v, common denominator is 1 minus v, so minus v plus v squared over 1 minus v here. Okay, keep going. What do we have here? So 4 plus v squared over 1 minus v. And then I got x on the other side, and all the v's are on the right now. So I can do variable separation, and that means I'm going to have 1 minus v over v squared plus 4 dv on this side, and then I'm going to have 1 over x dx on the right side. Okay. Take a look at the left side. I can change it into two terms, 1 over v squared plus 4 dv minus the integral of v squared plus 4 dv equals to ln x for sure. And then I recognize that 1 over v squared plus 4 has to do with arc10. And then the second integral, well, v squared is 1 degree higher than v, so I know that this has to do with ln. Let me make some room. Let's continue on this side here. Okay. If you want to show your rough work for the first integral, remember that we have 1 plus x, right? So v to, this is v squared plus 4 square root. We're using this particular substitution here, okay? So here we have arc 10 v over 2. Okay. And then the second part, let me show it. If I let u to be v squared plus 4, du is 2v dv, which makes this into 1/2 ln of u, which is v squared plus 4. Okay, and this is equal to ln x. I can do the plus c on either side, doesn't really matter. So here we have all this mess here. Let's try to simplify it slightly. I have the halves, so I can say that arc 10 over v over 2 minus ln v squared plus 4, I can put the plus c, I guess, is 2 ln x. And now I can substitute v equals to y over x, because I want my final answer in terms of x and y. Then arc10 y over 2x minus ln of y squared, or 4 plus y squared x squared, is equal to, or plus c, is equal to 2 ln x. Okay, so this is an implicit function, but we can leave it in this form. Okay, number 3. Find a particular solution to this differential equation given the initial condition y at 1 is equal to 2. Well, we know that in order to solve a homogeneous differential equation, we need to isolate dy by dx so that we can make the substitution for that product rule formula, the big star part. So here, let's divide both sides of the equation by 4x. We have x over 4x is 1 over 4, plus 2y over 4x is 1 over 2 y over x. And if I let b to be y over x, dy by dx would then equal to x times y's derivative, so x dv dx plus v dx dx. Okay, so here we have x dv by dx plus v equal to 1 over 4 plus 1 over 2 b. And then if I try to gather like terms, here I have 1 over 4 minus 1 half b, because positive half minus 1 is negative half, and x dv by dx. If I factor out 1 over 4, I get 1 minus 2v as x dv by dx. After this step, we can now separate the variables. I have dv over 1 minus 2v integral on the left, and on the right, I'm going to have 1/4 times the integral of 1 over x dx. Okay, I know how to take the integral of both sides now, so I have ln 1 minus 2v negative 1 over 2, okay, equals 1 over 4 ln x plus c. If I multiply both sides by negative 2, I'm going to have this. Okay, I don't really have to, change c because it's just a constant. And then if I want to get rid of the ln on the left side, I will have to take e of the right side, but e to the power of plus c, I can change it into the constant a, like how we did in previous lessons. And let's look here. Negative 2v, or positive 2v, I can make it, is 1 minus a times e to the power of negative 1/2 ln x. But this, using a shortcut, is a times x to the power of negative 1/2, okay? Assuming x positive. Since b is y over x, in other words, y is x over 2 multiplied by 1 minus a x to the power of negative 1/2. And for the particular solution, what was our initial condition? Our initial condition was y at 1 equals to 2. So here, we will sub. Okay, so 2 is now equal to 1 over 2 times 1 minus a x to the power of negative 1/2. Oops, x, I can replace it with 1. So that's really 1 minus a, correct? I have 4 equals to 1 minus a, or a must be 1 minus 4, which is negative 3. As a result, y is x over 2 times 1 minus 3, negative 3, so plus 3x, like that. If I want to clean this up more, I can multiply x into the brackets and get x plus 3 root x over 2.